Okay, let's get started. Hi everyone, I hope all of you are well. I'm so glad to be here, and today I'll be talking about linting Python the elegant way. A small introduction about myself. My name is Riya Bansal, and I'm currently working as a software engineer at Microsoft. And I was also a speaker at PyCon Berlin as well, which happened very recently. So this is actually my second talk at PyCon. So let's get right into it. So, before starting our discussion, I would like to talk a little bit about what you can expect from this talk. So, you can expect to learn about what exactly linting is and what are the different linting tools available. Why do we really need linting? And a very common misconception, we'll talk about the difference between linting and formatting. We'll also move on to talk about what are the different linting tools that are available to us, and we'll see a small demo after that, where we'll take a demo with one of the linting tools that are available. So to get started, what we will do is we'll actually take a look at one of the code snippets first that I have created myself. So you can see that here I have created a small class on searching, and here we basically I've created a constructor and two of the popular searching algorithms that we use, which is binary search and linear search over here that I have created. I'm not going to go too deep into the algorithm. I'm going to assume everyone would have used these algorithms at some point in their life. So the thing that I want to talk about with this code is that what you will see on the screen is a valid Python code. All of this will run just fine without any updates over here, and it will just show you the required output you're looking for. But let's take a very close look at this code over here. What you will see is, and when you will go deep into this, that the code is not really that readable if you take a very close look. And then you'll start noticing a few errors in here as well. For example, you will see there are some variables that are unused. For example, in line number 9, this answer equal to 0, which we're never really using. And then we have tabbed differently also at multiple places at, I think, line number 19 and then 16. The tabbing is very inconsistent. And even the naming conventions is not very consistent. You will see that the name binary search and linear search are used very differently. And eventually, down the lane, what happens is these things make your code very difficult to maintain, and they can potentially create a lot of problems when you share this code with your teammates, developers, or amongst your community as well. So it's wise to always conclude that yes, formatting matters. It makes your code very easy to debug, and it is going to help everyone that you're working with and not just you. Whenever we are writing code, and that is true for almost all of us, that we think that writing code is just about, writing correct logic, right? But seldom do we realize that it's also about formatting it in a consistent way so that it's reusable, optimized, and understandable. So over here, sometimes what happens is there is some sloppiness in the code, which if not removed can lead to actual bugs in the program. Usually one thing that I see is very consistent is that developers who are struggling the most to fix the bugs are often the same developers who do not spend awful lot of time worrying about what their formatting is, or they do not have consistent formatting at all. I'm not saying that it's always true, but yeah, there's definitely a correlation over here. So now when it comes to Python, there is a proposal called PEP 8, known as Python Enhancement Proposal 8, that is 100% about formatting. Some of the common rules that we have in it are spaces, not tabs, the very big discussion we always do. Variable name, as in camel case and not in variable name or the Pascal casing that we use. And it's always good to avoid extraneous spaces which are not required. As in the example, you'll see there's so many spaces over here and we do not need them all the time. And these rules are just the tip of the iceberg. And there's a very good chance that you're not going to remember all of them. This is where the term or the tool linting comes into play. So linting is one such tool that helps to identify potential issues with your code base based on style guides, naming standards, typos, and bugs too. But it just doesn't do that. It is actually a part of a larger picture of code quality as well. So Linter is kind of a very good tool to look into. So we'll take a deeper dive in it today. So Linters are programs that advise about code quality and give feedback on your Python code by displaying errors and warnings. They can detect your Python code mistakes, notice invalid code patterns, and find elements that do not follow your conventions. It is more like a robot tutor for your Python program. It is a great way to ensure minimum quality standard to your code base. But what happens is, whenever I talk about linting, people think that linting and formatting is just like, terms which we can choose interchangeably, and linter is just another formatting tool. And it's a very common misconception. The truth is that it is actually much more than that, and the two terms cannot be used interchangeably. Linting is different from formatting because linting analyzes how the code runs and detect errors, whereas formatting only restructures how your code appears. Linting also make your code look like it was written by a single person. They spread awareness and ownership over your code quality. So now that we have taken a little bit idea about linting, we'll also take a look at what are the linting tools available to us. So there are many Python linters that you can leverage in your day-to-day work. Some of the popularly used linting tools are Pylint, Flake 8, and PyFlakes. In this talk, we'll talk about one of my favorites, which is going to be Pylint. So now we're going to go back to the code, and what we will see over here is the basic setup that you need to do for your linting tools. So installing Pylint is very, very easy. So Pylint is essentially a Python module which you can install using pip or conda or pretty much any package manager you want. So if you go over here and if you simply do view, and if you go to terminal, and if you simply do pip 3 install Pylint, and that's pretty much that you need to do in order to install Pylint. And there you go. You can simply now run the command after this, which will be Pylint followed by your file name and .py. That's it. That's pretty much that you need to do in order to use Pylint. And once everything is set up, we'll go ahead and take a look at the code, which we actually write in the start. So here, if I do Pylint code example.py, we will be able to see all the feedback that Pylint basically has for my code. So let's try to read this a little bit and understand what exactly is happening over here step by step. So here, if you will see that there are different columns over here. First column is basically the line. So if you see 16 over here and then 24, 8, 27, that's essentially the line where the feedback is provided for. The second is basically like a code for the error that it basically is. For example, if you see a C over here, it means code style. If you see a W at the top, you see W0311, that's pretty much a warning. And we actually have a lot more than that as well. So we have information whenever there's like an information message that Pylint basically emits. R is for refactoring, C is for a simple coding convention that we follow. W is a warning for stylistic problems. E is an error for important programming issues, and F is a fatal error that the code has. And then after that, the third line or the third, I think, column over here is basically a short description that is there about your code. So let's see the first error. I'm going to pick the easy one right now. So it says at line number 14, there's a bad indentation. It says it found 20 spaces over here. So if you actually go on line number 20, you will notice that it is indeed correct. I'm sorry, I'm not able to see very clearly. Here it says bad indentation at line number 16, which is indeed true. So what I'm going to do is I'm going to go back and correct this indentation over here. And now if I will run the same command again, it will pretty much make sure that the error goes away. So now if you will see the error, that indentation error for line number 16 essentially is not present anymore. So that's how you basically work with Pylint. You check an error and then you see where the error is, what kind of an error is it, and then you just fix that error. Along with that, one thing that you notice at the end over here is like a score, that is basically Pylint is going to print out for you to analyze your code. So it's a small score. It basically, I think the maximum value is 10 over here, and there is some metric that it uses to analyze your code. But I would recommend being careful with these metrics, because while writing code, it's very difficult to come up with, an accurate metric that always gives you valid feedback. I have seen managers coming into a room and saying, oh, we're gonna optimize code quality and, work on code quality and improve this particular metric. But soon what happens is that people in the room start, or people in the team start optimizing on that particular metric itself. And trust me, it is possible to write code that has no business value and logic, but it still has a very good score. So always take these metrics with a pinch of salt. But that being said, these are still very useful and healthy metrics. So it's always good to have a good score. And even if you don't think that, all of this is still a very valid feedback. So what we're gonna do is we're gonna try removing some more errors over here. So let's say it also says that you have a constant name element to be found in the global, but it doesn't follow the convention. So I have something as element to be found, but I'm not really using the right convention. So let's just fix it. So if I do this, and if I pass it correctly now, the error should go away. So currently my score is 5. I know I'm not doing a very good job, but yeah, you see, it kind of increases my score a little bit over here. So one thing that I really, like about Pylint is that it's sort of like a gamification aspect over here, right? I'm improving and I'm making my code better, and along with that, my score is also, I would say, improving as well. So it makes me feel a little better about myself when I am working towards a better score over here and, improving my score constantly. For example, if you also see over here variable name current index, over here that we are using this, it doesn't again follow the casing that we really require. It should be a snake case, but we're not really using it the correct way. So you can just simply go to edit, you can go to replace, and then if you just want to fix that up, you can just do this, and if you click enter, it should pretty much correct wherever it is being used. And now if you will run again, you will see that, oh, we actually moved towards a bad score because we probably would have missed something over here. Okay, yeah, there's like, we didn't fix it at all the places. So let's fix it. And now let's see. So it's like the score goes above and down based on how you are fixing it. You can see also that we are using an unused variable over here, which happens quite frequently. So it's always good to have these checks in place. So now that we're doing it, we don't have to pass anything over here. So if I fix that up as well, it should again pretty much increase my score a little bit over here. So did we do unmatched? Yes. So you can see how helpful the tool exactly is, and eventually your score kind of becomes better at all times. So you can work towards a better score. I think if I will remove all the errors over here, it will eventually give me a score 10 on 10. But again, you don't have to strive for a full score. It's always good to just make sure that the conventions are being followed here really well. Okay. So now one more thing which I feel is kind of like a disadvantage with Pylint is that it's a opinionated tool. For example, let's say here in future, I do not really want to use linear search. So if I just go ahead and comment this, and now if I see what Pylint is saying for my code over here, it will say too few public methods, which in my understanding is a little opinionated. What if I really just need one function and I don't really need a lot of functionalities in my class? So always remember that Pylint is a little opinionated in that sense. It might point out some things that you disagree with, and that's where it's very important to know and understand that you can suppress some of these errors as well, right? It's kind of like, you can tweak it and tune it so that if there is something that you are doing intentionally, you might not want to see an error about that. And so for that, you can just simply, since the error is coming for the class over here, you can just simply go to the top. And for the class, you can just use the syntax where you are doing something like this. So the syntax is you write Pylint, and you have to use the all small case over here. So you do Pylint, and then you want to disable. So you can do disable over here, and with that, you can just put the error. So it says too few public methods, and if you do this along with this, right, essentially it should not really show you the error anymore, and you can see the error actually goes away. So yeah, that's pretty much a good way where you want to, you have some error, but you really don't want it to be there. So you can just like write this wherever the error is coming, and it will essentially go away. And if you just put it at the very top of the file, it will essentially make sure that no matter what class you've created, it'll not show that error for any of the classes. But if you just want it to be valid for a specific class, you can also do that as well. But obviously, one thing that you will also notice is that it can get cluttered after a little while, and if you are trying to ignore a lot of errors. So what you can do is you can also set up a configuration file. So that way, if there are certain rules which are not just like file specific, but like at the project level, you want to ignore them, you can go ahead and do that. So you can just create a file with the extension .pylintrc file that stores all the settings at the project level, and it becomes a little bit easier to manage your code then. So now the good thing is that even if you want to ignore a rule, you can just ignore it for one line, or you can ignore it for the entire code base as or entire project as well. However, it's not recommended to do that very frequently, because it's like you're taking an exception to a rule. And if you're doing that too frequently, it's not really an exception anymore. It's like you're avoiding a rule altogether. So if a linter is yelling at you to take care of formatting or the code quality, make sure you do take that seriously. So now that we have a little bit idea about, I think, what linting is, you can obviously work more about this and try to let go of more errors. For example, if you have binary search over here, you should ideally be using this. For example, you can see that there is some params are not really required over here, so you can get rid of those params as well over here. So linter will essentially make sure that it tells you all these sort of things as well, which essentially any other formatting tool might not do. So if you will go towards a batch score, here you see that you did make that change, but you did not call that function with that right value. So always make sure that you take care of these errors and you work towards better score. Other errors that you will see is that there is another indentation issue at line number 14. So here also it says that you've not done the indentation very well. You have found 20 spaces, but only 16 was expected, and you've not used docstring. So I just used docstring at the top, but I did not use docstring for every class, every constructor, and every functions that I have created. As well as the variable end index, similar to current index, is also not conforming to the cases that it is ideally should be over here. So if you will see end index, it's also not following that convention. So although you might not look at these errors from a very high level point of view, but these errors actually contribute a lot when you're fixing bugs and when you're looking at a code and trying to make it look like it's a standard code, and it helps to ensure a minimum quality standard is indeed intact. So now we'll also take a look at some of the advantages that I think Pylint as a linter provides. It helps to prevent bugs in a project that we have talked about in detail. And it also makes you make sure that your code is readable to other programmers, and it looks like one consistent person has written that code. Along with that, it also catches unneeded pieces of code as well, which might get overlooked by a naked eye. Of course, every approach and every tool has disadvantages as well. Sometimes linters can return false positive. For example, you just saw that too few public methods wasn't really an error for me, but it was still showing an error for me in that case, because that's how linting works. Also, this process can be a little time consuming for very large project. Essentially, it'll be a whole bunch of files that comes in as an output where you see the error from linting. So the process is a little bit time consuming because you have to go to each and every line and then fix it. And also some errors that could be overlooked are not really overlooked by Pylint as a tool. But still, there are many advantages of using linters greatly that outweigh its disadvantages. And in the end, I would like to point out that although formatting and linting tools are great, do not completely rely on them, as there is only so much that they can do. For example, in this case, the linter could not identify that the code that I've written over here for mid index can actually lead to an overflow. Rather, the better way of writing this would have been start index plus end index minus start index by 2. So essentially, linter could not identify that. So make sure that you don't really completely rely on this tool over here. And these practices for linting and formatting were not really just like introduced right now. I think Tim Peters defined Zen of Python, I think in 1999, and where all the guiding principles of writing computer programs using Python have been clearly defined. And if you ever want to revisit that, and if you ever want to take a look at it again, it's actually very simple. So if you simply do Python 3, and if you do import this, it essentially shows you all the rules that has been defined for Zen of Python, which says beautiful is better than ugly, explicit is better than implicit. I think there are a total of 19 rules over here where it says complex is better than complicated. So yeah, please make sure that you do take care of these rules, and linters as a tool come as a great advantage for this. And in the end, what I would say is that always try to develop the habit of writing clean code and make it a part of your daily developmental practices, and using linting as a tool which helps you as a companion and you don't really always solely rely on it. Yeah, that would be. Thank you.
Thank you. So we have two questions. The first one is, autocorrection package recommendation, most issues should be able to auto-resolve instead of manual connection.
So autocorrection package recommendation, most issues should be able to auto-resolve instead of manual. Yes, I do agree that if you're using on a big, as a project level thing, it should take care of it. And linting is more or less like a tool which is very, I would say, recommended for complete beginners, as in if you're trying to get into it and you're still becoming comfortable with the code base and working on a basic functionality, it really helps to become comfortable with the syntaxes whenever you're getting started with Python, and you're just shifting from one language to another language. So there's like different conventions that you follow. So it's always a good practice to use it, and preferably that way. But yeah, that being said, there are a lot of like recommendation tools available. In fact, in VS Code that I'm using over here, you can integrate as an extension linting tool here as well. So you don't have to run exactly Pylint command automatically. Even when you're writing the code, linting kind of suggests the errors and recommendations at that time itself. So yeah, that.
Okay. We have another question. How to choose between Pylint, Flake 8, black, etc.?
Okay, so whenever we use Pylint, to be honest, even I prefer sometimes PyFlake instead of Pylint, because PyFlakes is a little less opinionated and it only shows constructive errors that we have in your code. But Pylint is more like, it's like more strict tutor that you have your code. It gives you more opinionated errors, and in terms of, I would say, working as well, Flake 8 is a little bit less opinionated, and in terms of error that it gives as well, they're far less, I would say, strict compared to Pylint. So based on what kind of suggestions you're looking and how comfortable you are with the language and how would you, really prefer to use it, you can choose the tool that you really like. But I would recommend that for beginners, I would say Pylint is a great tool that you can use.
We have another question. Should linters be used in pre-commit hook to check code?
Yes, I would highly recommend that, and that's actually a very great practice to do that, because when you're pushing the code, before that, if there's something that is, checking your code and making sure that everything is right before you actually push the code, it actually comes back biting at you a lot less compared to when you are taking a check before actually pushing something. So yeah.
Any more questions? Any questions?
Thanks. So, do you sometimes have the problem where you use external packages or libraries, like, for example, Python requests, and Pylint says that you need to install external packages to relevate other problems. Do you often have this problem, and how do you solve it? Maybe.
So you're saying that whenever we are dealing with external packages, there might be a case that Pylint as a tool is telling you to do something in terms of that packages itself. Is that it? Yeah, I think a Pylint as a tool does take care of that. I think with the new versions of Pylint that is coming, it is actually becoming more comfortable with how the external dependencies are being taken care of. Earlier, I would say that the language was a much more stricter. It even gave errors when you just used an extra space and everything. But yeah, in terms of like the way Pylint is working and evolving right now, it's actually giving a lot better errors, and it gives you relevant suggestions, not in terms of what external packages you are using, but also in terms of how you are importing them, what should be the correct ordering, which import should not be really used, and which import is like, so it's like a suggestion that it gives for slightly better options that you have available.
Any questions? Okay, so thank you for your talk, and thank you all of you for joining.